porting .NET Core applications, porting to .NET Core applications. So we already are having a lot of .NET Framework applications, and for reasons we want to now migrate .NET Framework applications to .NET Core. So first we have to understand what is that we can migrate and what we cannot migrate, and subsequently we are going to look at different tools which will help us to decide what part of our code is not compatible, and if it is incompatible, what are the options we are going to have. So these things we are going to cover one by one. So first and most important thing, what are the reasons you want to port to .NET Core? One, you can build highly scalable web apps. Because of its architecture itself, .NET Core applications are considered to be very scalable. They can support a lot of clients, they are pretty fast, and that is one of the major reasons I would want to migrate to .NET Core. Not necessary it should be only for Linux. Even on Windows, even on IIS, I would like to probably migrate from ASP.NET to ASP.NET Core. Yes, if you want to run your web applications on Linux, basically console applications or web applications, both of them, then also there is a reason you have to migrate to .NET Core, because .NET Framework is not supported on Linux. You have self-contained deployment. I told you yesterday, we can package our application in such a way that without any dependency on the framework or any external dependency, the whole application can execute by its own. On its own it can execute. So in such kind of case also we would want to migrate to .NET Core. Yes, why we do not want to migrate, why we can't port our application? One major block, we do not have all the APIs of .NET Framework covered up in .NET Core. We still have certain APIs which are incompatible, rather which are not available in .NET Core. So that is one reason I may not go for it. Or I am doing already desktop applications, WPF applications, or probably Windows Forms applications. These applications as on date are not available in .NET Core. And then we have already used ASP.NET Web Forms, ASPX files, ASMX files, those kind of things if you have used. Yes, there is no support for the same in .NET Core. You have support for MVC, you have support for HTML forms, but you don't have for web forms. So compared to other stacks, specifically the .NET Framework, Mono, Unity and Xamarin, .NET Core does not provide the same set of APIs. This is going to make porting assets to .NET Core quite challenging. This is the basic statement, because the APIs are still not enough. Yeah, they are enhancing with every version. 2.0 has bridged lot of that gap, but still there is a gap where they say all the APIs are not available. So, and most of the times there is no replacement also. That's the worst problem. That is the worst situation. We don't even have an alternative. So before porting any source to .NET Core, you should understand your code base. What is your existing code you have to understand. What is the architecture of your application you have to understand. What are the external dependencies? What are the DLL files on which your application is dependent on? These things you will have to understand. So .NET Core has to offer what and what it is not offering. All this you'll have to clearly understand. I mean, the complete knowledge of .NET Core what we have till now is very essential to make a decision of whether to migrate, whether to port an existing .NET Framework application to .NET Core or not. So these are the applications which are supported now: console applications, ASP.NET Core web apps, ASP.NET Core web services. We have universal Windows application platform apps also can be developed. Class libraries in .NET Core can be developed, but I told you it is always recommended to go for .NET standard libraries rather than going for .NET Core libraries. The technologies which are completely discontinued, now we don't have anymore the concept of app domains. We earlier had the concept of app domains, but now absolutely zero. No code isolation and all that. So for code isolation, Microsoft recommends go for different processes, different EXEs, or go for containers, Docker container and stuff like that. That's what is ideal recommendation for code isolation in modern programming. They recommend for dynamic loading of assemblies, they recommend new assembly load context class. That's the class which has been introduced, which can be used for loading of assemblies dynamically. Remoting, as it is actually killed, but was always supported in .NET framework. People have replaced remoting with WCF, and then eventually now RESTful API is more common. So remoting is completely discontinued. For common communication across process, inter-process communication, such as pipes or memory mapped files, these are supposed to be used as an alternative. Across machines, you need to use network-based solution. Something like REST API using HTTP is a preferred option in today's world. So on same machine, use IPC, use classes related to pipes, memory managed files on the hard disk. Those are the solutions basically. Binary serialization is discontinued. Yes, we have always the option of using data contract serialization, XML serialization, JSON serialization, which are all interoperable. See, basically those things which cannot be interoperated, they are discontinued in .NET Core. Because now the applications have to be supported on Linux. On Linux, these concepts cannot be implemented. Binary serialization has the basic problem of binary format of data, which is compatible to Windows. That is not compatible to the other operating system. So that's why binary serialization itself is suppressed. Reflection. Now we do have reflection support, but for that system.type is no longer represents the full-blown reflection type. Remember, for every class there is a class loader which is responsible for loading the class. For every class there is a loaded version of the class, and the loaded version of the class is supposed to be represented by system.type. Now system.type in .NET Core no longer contains API methods such as get members. If at all you know reflection, we have got methods like get members, get properties, get methods, get constructors. For a given type we can get the list of all its members. Like that we can get for a given method all the parameters, return type. That API is no longer present in system.type. So in case you want to get that information, what is the solution? You have to use on type something called as get type info, and get type info is part of reflection API only, but the small change which is going to happen is earlier we wrote object.getType and then we wrote get members. That is what we wrote. But now under reflection API we have got type info, so we are going to write object.getType .getTypeInfo.getMembers. That small change is going to happen now. This get type info is supposed to be extra, which is not compatible with the older .NET framework. So basically point is you will need to make some adjustment to the code. That is the main point actually here. There are cases where the old code has to be replaced with new code. It's not that 100% everything is compatible. Few things are, few things are not. Namespaces that are not supported or partially supported, you don't have any more system.data. That's completely gone. So base layer that is already part of .NET Core, either the provider, basically we have to use something like SQL client, direct system.data.SQL client, that is supported, but system.data is not supported. and dataset would be part of such types only, but still they don't have schema support. Like if you remember, there is something called as type dataset. The type dataset concept is not there now. System.directory services, LDAP support, Active Directory support was tightly integrated there. But these are again specific to Windows operating system, hence not supported. System.drawing, obviously drawing is something which will be used for creating images, some kind of painting on the screen, and we do not have any support for this. We don't even have an alternative to system.drawing at this point of time. System.transactions, which are basically for ADO.NET transactions. So there is nothing called as, I mean, if you know, there is something called as, what is that? Distributed DTC, Distributed Transaction Coordinator. That was internally using the classes under system.transaction. Called major class was transaction scope. Now transaction scope or DTC was a service which is related to specifically Windows. It doesn't work on other operating systems. So we don't have system.transactions support. So ADO.NET supports transaction. That means SQL connection we can still use to get the transaction, but the distributed transaction support is not available. System.xml.xsl, xml.schema. We have got support for XML document. Link X document is also there. Basically, we have alternatives for this. System.net.mail. Sorry, actually this support has been given in 2.0. So I can delete this. System.net.mail has come now in 2.0. It was not there in 1.1, but in 2.0 it is there. 2.0, 2.1 it is there now. .NET Core currently doesn't include ability to communicate with serial port. That's a problem. Workflow Foundation is not available in .NET Core. XAML absolutely not available. So these are few things which you should know, what is supported and what is not supported in .NET Core. Now how to verify? Suppose if you are trying to refer to a particular NuGet package, you need to verify if the NuGet package is available for .NET Core applications or not. Or in other words, what are the .NET implementations for which it is available, where it can be used. That I would want to verify. So obviously there are two approaches for this. There is one which is NuGet Package Explorer, and that's pretty reliable is what Microsoft says. So we have to use this NuGet Package Explorer. Open the package in that, and it will give you the list of .NET implementations where the NuGet package is supported. So if at all we find that the not compatible with .NET Core and only targets .NET Framework, we have a choice actually. If you have a particular package which is not compatible with .NET Core but is compatible with .NET Framework, you can check if .NET Framework compatibility mode can help for porting the application. Let me explain you. First you have to do is go to this particular URL and install NuGet Package Explorer. On your local machine you'll have to install it. So I type NuGet Package Explorer. Choose the option. I don't want to use the local package. I want to use the package from online feed. Now I want to check if there is something. What? You can choose Newtonsoft itself, the first one, most popular used actually. Just double click on it and Newtonsoft has opened. What is important is this part. Based on these monikers, these are framework monikers. Now you can know where all this is supported and where all it is not supported. So though I do not have .NET Core app, I still have .NET Standard. So I can always build a .NET standard library, and in .NET standard library write my code and use that in .NET Core application. Direct .NET Core is not there. .NET Framework is there. .NET Standard is there. Likewise, maybe try system dot. There is no direct shortcut to switch. No direct shortcut. So I go to Package Explorer, another instance. Search for maybe something like system dot what data dot SQL client. And yes, we have system dot data dot SQL client. SQL connection, SQL parameter, SQL data reader, SQL command, SQL transaction. All these are what we use for executing our SQL statements. So that support is there. But on which frameworks? Just double click on this. And you will notice here under library, you have got support for NetCore also. Directly in .NET Core application you can use it. In standard libraries you can use it. In Xamarin you can use it. .NET Framework obviously you can use it. Mono.NET you can use it. So it's a very good tool where we can figure out what components are available to the different implementations of .NET. So first, all your dependencies you have to make a table. Whatever dependencies are there, something like this, you will have to do an exercise and figure out if these are available in .NET Core or not, or they are only available in .NET Framework, not in .NET Core. So that table you will have to make, and then find for those what is not available, what is the alternative. That's the approach you have to take. So that's how you can take the NuGet Package Explorer, the support of NuGet Package Explorer for migrating your existing .NET Framework applications to .NET Core. These are all framework monikers. These are for portable libraries. .NET Core. Now we have .NET Core 2.1 also. .NET Framework monikers, they are called as. Now there is another tool called as .NET API Analyzer Portability. Let me do one thing. I'll just open some project on my machine. Some sample project it is, which is actually in .NET Framework. It is not .NET Core. Then you'll have to go to this particular location. .NET Portability Analyzer. You have to install this .NET Portability Analyzer, and it's going to give you a Studio plugin which will have this look and feel. There is some tool called as API Port. Here you have to go and install it. Let me open this also. Microsoft Marketplace, you can install this portability analyzer. Analysis of a single project solution or binaries. Analysis against multiple .NET platforms simultaneously. Generates the reports in multiple formats. So if you already have a project, see NuGet Explorer you are supposed to use if you need to target a NuGet package. But we are not talking about NuGet package now. Now my project source code is already there with me. So that I want to analyze now. So go to analyze and analyze assembly. First go for portability analyzer settings. And put a check mark for what all frameworks you want to analyze the support for. So let's say I want to check for .NET Core, and that is my primary purpose. Click on OK. Now go to Solution Explorer, right click on the project, anyone, and choose the option Analyze Project Portability with project references, including references. And this is going to do all the code calculations in background. Whatever code you have used, it will do complete analysis of all that, and it will give you a report. And through that report also you can know which part of your application is incompatible. Now it is doing that analysis. Report is generated. So now click on Open Report. So 4 projects, and what is the percentage of compatibility is given here. Developed in these frameworks, and these are the compatibilities. You can go to actually details and look at the details about what is compatible and what is not. So we have HTTP controller descriptor. These are all so many coming because of the dependencies, references which I have included. HTTP properties key, all this I have used. That's the reason such a big list is coming. If it is only my code which is taken, I'm pretty sure will not get this much error. These are all external dependencies. These have nothing to do with my code. None of them is my code actually. So let's close this. Again go to settings. We can generate the report in HTML format also, JSON format also. We got so many. Let's say we open the HTML version. And it clearly says what is supported and what is not supported. Now you have to figure out the constructor of application insight. Basically application insight support is not there. My project is using application insight. So this is the class which is not supported. In that class, it is specifically saying this particular method, the constructor, which I have used. More appropriate, more specific report. Get request. So once I know this, these are again classes which I have not written. These are all part of framework. It will be easy to migrate these things. These things I have to ignore it, because if I migrate my source code would not have all these things. The only thing which my source code is referring to right now is this particular class. I am using this class for application inside. Let's, just for the sake of understanding, what we will do is, one of these we will use in our project. Let's say system.transaction I'll use in my project. And there we write code. Using system.transaction. And here we have to write some code, and eventually we have to say dot complete. Some code has to go here. I'm not worried about some code. Now let us run the analyzer again. Now it should have mention of that particular piece of code also. It's not listing system.transaction. Let's see, NuGet package explorer, and I try to explore now system.transaction. Not there. Why it is not giving error? Oh, the latest is here. The latest is here. let's do one thing. Transaction scope they started supporting in 2.0. In 1.0 it is not supported, so my notes is not updated. So that was the problem. So this needs to be updated. This is now there in 2.0. So maybe some more might be there which are probably already included in 2.0. System.drawing is for sure not included in 2.0. Rather, it will not be supported in future also. So that code we can always write here. See, bitmap is a class. Those are supposed to be used for creating an image. Now if I analyze this, and open the latest report, we should have bitmap also here, which is not supported. Bitmap not supported in .NET Core 2.1 to 2.1. All the places bitmap is not supported. So that's what, this is an excellent way of figuring out what is supported in our code in the different versions of .NET framework. This is going to be very, very, very handy. So two things we have seen. One, what is supported in my project and not supported in my project. This is at the project level. But if I'm not worried about the project, if I want to use a NuGet package, and through NuGet package, if I want to know what is supported or not supported, we use NuGet package explorer. These are the two very useful options to figure out how difficult it would be to port your .NET framework applications to .NET Core. So this whole table I'll have to update it. I'll do it later. So NuGet package explorer, that's what I explained to you. Yeah, there is a command line utility also for it. You can download a command line utility. API port is the utility which you can make use of. You try this on your own, and same thing we can do it on the Linux also, the API port. Then there is something called as reverse package search. So what you do is go to this URL. This is also very handy feature. And type what you want to search for. Let's say I want to check system.transaction scope. Rather just type, system.transaction scope, search. Where all we have system.transaction scope, those packages will be listed here. Maybe only transaction scope. Something wrong. Drawing. system.drawing, in which all frameworks, it is reverse package search. You should put the class name and it will tell you in which package that class is present. Transaction is not present anywhere. Not showing. What shall I search? SQL connection. .NET Standard has support for it. Data set. .NET 2, 3, 4, 5. Only .NET Framework support is there in different packages. But this is not even system.dataset. I mean system.data.dataset. It's a Newton. So based on the class name, we are going back. Reverse package search we call it. Entity context. What is that? System dot entity itself. Entity framework. System dot entity. So this also is, I mean, just for reading purpose. That's it. To explore before you start using it. To explore which particular package, which particular NuGet package the corresponding class is present. This you can use it in general actually. It has nothing to do with specifically porting. Then there is a feature called as .NET Framework Compatibility Mode. What we do here is, see, after analyzing the NuGet packages, you might find that there are only target frameworks, .NET Framework, that's it. But now I want to use .NET Framework code in .NET. So what they have done now is they have written a lot of classes in Microsoft.Windows.compatibility. A Windows compatibility pack has been created for .NET Core. So NuGet provides that Microsoft.compatibility pack, and this we can use in our .NET application. Let me show you one example. I'll create a new project, or let's open that yesterday's project only. Say standard class library, or .NET Core library will take better. And here I write this function. Now what is important is to be noted, in this function we are using registry class. Registry class is not supported in .NET Core. It's not there. But it's supported in a NuGet package, which is, it is part of Windows Microsoft.Win32 registry, but that is specific to Windows. So now if you want to use registry in .NET Core, knowing that you are going to include this code only for .NET Framework, .NET applications which are going to execute on Windows. I'm making an assumption that this code will work only on Windows, and I want to use that class now in .NET Core. See, understand this point. We are trying to migrate some piece of code from .NET Framework, so from .NET Framework to .NET Core, and I'm okay to execute this code only on Windows. I'm not interested in interoperability with other operating systems. So I want to now make this work. So what I do, I just go and add the reference to the NuGet package, Microsoft Windows compatibility. In my dependencies, a NuGet package, Windows compatibility, I add it. Install. The Windows compatibility package provides access to API that were previously available only for .NET Framework. That's the advantage. It can be used from both .NET Core as well as .NET Standard. So I say accept, but the only problem is it adds huge. On your machine, lot of libraries will be downloaded first, and then now go back to this code and you'll see it works. Just say Microsoft Windows 32 on top and the code works. It will compile and execute also wherever you are calling this function for logging operation. But if I run the same project on Linux or Macintosh, this is going to fail. It will crash. So in those kind of cases, what to do? There is a provision where we have a ready-made condition check. We can check. Maybe we can write here, if this condition is true, then only do this. And this is part of, again, system.runtime.interop services. So we are checking if the platform is Windows. This kind of check we'll have to do now in code. If the platform is Windows, then return the configuration path which is coming from registry. Otherwise, we frame our own path and return that. So now this piece of code, because of this additional conditioning, will work on Linux also. On Linux, it will return a custom path framed here, whereas on Windows, it will return the path fetched from registry. So like this, we'll have to resolve the problems in situations needed. Now this is the basic recommendation for porting overall. Identify the project you want to move to .NET Core first. Understand the external dependencies these projects have and ensure that they are either compatible with .NET Core or have equivalent alternatives that can be factored out. Now, ideally what Microsoft is recommending is, before we move any project from .NET Framework to .NET Core, first change the whole project to .NET Framework 4.6, because compatibility with 4.6 is much better when compared to the previous older versions of .NET Framework. Because when you are migrating from maybe 3.5 to 4.6.1, there itself lot of things you might change it. So this ensures that the API alternatives you have introduced for the cases where .NET Core couldn't support existing APIs. So basically the point is, most of these things which are there in .NET Framework 4.6, they are mostly supported through the Windows compatibility pack. That's why it is recommended to go for .NET Framework 4.6.1. So through Windows compatibility pack, we will get that feature. Then create a new .NET Core project, move your code unless there are more issues than API port couldn't detect. I told you API port itself is going to detect. You should be able to compile your code successfully. But even now, if suppose API port is not able to give you clean report, that means there are still certain piece of code which is not portable, then you should try Windows compatibility pack. Windows compatibility pack is covering, I think 20,000, 10,000 or so many classes, 20,000 APIs. 20,000 APIs are there, of which 20,000 APIs, few are Windows only and few are cross-platform supported. Remember, this particular pack is a separate pack than the classes which we are using in the .NET framework. It's a separate NuGet package Microsoft has built for the sake of portability. It's a completely new implementation of those classes. Basically, they should have written some wrapper around the basic classes. Windows classes, they should have created wrapper, whereas certain other classes, they should have created implementations which are cross-platform. Like that, they have provided these things. Try the Windows compatibility pack, recompile, run the API analyzer, API tool, make sure that it's clean, and once all the issues are free, you are done. That's it. You have to repeat 4, 5, 6 till you get clean report. And this is something funny, but Microsoft recommends what to do when NuGet package dependency does not run on .NET Core. This is a recommendation. If the project is open source and hosted somewhere like GitHub, you can engage the developers directly. That means, like I showed you some website where you can go to GitHub and propose to the developer, hello guy, please provide me this support. I need it in my project in .NET Core. So that open source guy will have to take care of implementing the functionality for you in .NET Core. You can directly contact the author, search for the package, click owners and figure out. You can search for another package that runs on .NET Core. That means if this package is not supported, find out alternative. You can attempt to write the code on your own in the worst case. And ideally, you should eliminate the dependency itself on that package. I mean, these are the only options. Logically, none of them are sensible. When we have dependency on a package, it is asking you to get rid of that dependency or write that dependency in your own language or ask the developer who has provided that to give you an alternative for .NET Core. These are the only options available. Unless Windows compatibility pack answers it for you, or you yourself know this is the equivalent of this class in .NET Core. So these are the tools which only when you actually practically migrate a project will be very useful to you. You should do hands-on migration of the project. So actually what happens, okay, I forgot to mention this. When you migrate from old project to new project, old version of .NET Framework to Entity Framework, .NET Framework 4.6, you start using more NuGet packages. Rather than using the local add reference concept, NuGet packages are going to be used more in this particular version. Everything we add through NuGet package only. So first idea is to get rid of those global assembly cache and start adding the references from NuGet package. That's the whole idea first. Let's have a quick preview from top once.
I have a question.
So what we want to port, what we can't port. That is very clear here. These are the applications which are only supported. These have been completely eradicated in .NET Core. No choice. Reflection has changed a bit. We are still able to achieve most of it, but we have to add this extra call. This needs to be revised. It looks like this is in context of .NET Core 1.0 and 1.1. Certain things would have changed in 2.0. We'll have to figure out. I'll have to update this part of the notes. I'll do that. Then you have got NuGet Package Explorer. NuGet Package Explorer should be used in situations where you are supposed to refer to a particular NuGet package, and is that available for your .NET implementation. Maybe .NET Core, maybe .NET Framework so-and-so version, or whatever. Every NuGet package can be analyzed. That is a very important. You are going to see the list of all monikers under library section when you expand it on the right hand side. Then there is a tool which is very handy, API analyzer tool. The advantage of it is it integrates very well with Studio, Visual Studio 2017 or 15. That's it. Once you integrate, you provide settings for the analyzer, what all frameworks you want to analyze the report, what type of format you want to have the output, all that you can provide in the settings. And when you analyze, it generates a report and it clearly says you this particular functionality which you have used in your source code is available and not available. Do that. Third thing you'll have to do is, this is also probably a solution in some situations, not always, because this is only read only, that's it. Only for knowledge purpose you might go to this particular service and check up your class is in which namespace or which package that you can search here. After all, if nothing is a solution, last comes to our handy is compatibility mode. So from .NET standard 2.0 only this compatibility mode is supported. That is also a limitation of it. If you are using .NET standard 1.x, 1.0, 1.2, 1.3, .NET framework compatibility mode is not there. So what to do for using .NET framework compatibility mode? In your .NET Core project, you add the reference to the NuGet package Microsoft.Windows.compatibility. Now through this Microsoft.Windows.compatibility, we are going to get lots and lots of Windows only classes as well as certain classes which are cross-platform. It's a combination. And those things now we would like to use in our project. This is the list of APIs which are supported through compatibility mode. So drawing is supported through compatibility mode. Direct support is not there, but through compatibility mode, system.drawing support is there. Say for example, I want to create some image programmatically on my web server. The image itself has to be created programmatically, so that I can create an image, save it as bitmap or save it as JPG and write that to the browser. We can do that. So for that in .NET Core we can use this compatibility mode. But you have to be careful when you are using Windows compatibility code. There is a very good chance that your project may not work on other operating systems. You might be getting exception. So you might find alternatives on other operating system, but for Windows, if you want to still continue to make use of that code, you'll have to use this condition. Runtime dot is OS platform. This condition you'll have to check, and through this condition you can figure out blah 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 blah. Chances are the .NET Core would give you compiler warning in case you want to disable the warning for this piece of code, because you know you have written this code. You can just give the warning number and disable that warning. That's your choice. So like this, you'll have to take care of porting all your .NET Core applications into, all .NET Framework applications into .NET